pretty slides rather than two, so I'll talk through them quickly. I'm slightly unusual in this place in that I'm multidisciplinary all by myself, which means I have several brains and I can talk to myself quite happily. It's normally fine because you don't get any criticism that way. What I do is quite mixed. I'm an electrical engineer, mechanical engineer, and I'm also part qualified accountant. So I've got a wide range of interesting things that go on in my head. Most of my work sits at the interface between these areas. Natural environment in particular, I'm very interested in the interactions between energy and the environment and energy. So the way that I've sort of split these up largely to allow me and others to track what's going on is I break them up into two areas. One is integration of renewables and the other is resilience and sustainability of power systems. So I do a wide range of different things. The integration side of it is very much focused on the idea of how do you get something that is highly variable, spatially distributed to work with a power system that's designed with very large individual power stations in mind. So the two aspects of that I try and bring into my work are how do you understand what the resources look like and how they vary, and how do you integrate them? To some extent they're quite separate things, but there obviously is one of the advantages of this is you can try and get these two things to fit. So the resource side of it is very much about understanding what the resources look like. There are other colleagues, Benke in particular, who are very big on wave and tidal. I've been more focused on wind, hydro and solar. But essentially what we're trying to do this is to use the best models that we can. So typically these are high performance computing models, mesoscale models like WRF, which are in relatively common use in industry. They're often applied in a very formulaic way, but they are there. And what we've been trying to do with those is model resources across very large areas down to quite fine resolutions. So at the moment we're able to do that across the whole of the North Atlantic for wind, down to about 3 kilometres. And part of what we're going to try and do next is to A, improve that, but B, drive the resolutions down to the orders of metres. So that requires us to find modelling techniques that allow us to bridge that quite large spatial gap. So that's essentially what we're trying to do, and that what that allows us to do is to look at what might be available when, and that allows us to characterise the resources, how they vary in time, how they vary spatially, and how the various resources interrelate. So that's quite an important aspect of it. The other aspect is much more electrically focused, or rather it's much more optimisation based in trying to understand, well, if you've got this varying pattern, how do you make best use of it in terms of operating a network and planning a network? So that's been, work there has been very much around development of planning and optimisation tools for operation and operational planning. So part of that has been about developing control systems that allow you to take these widely varying resources. Part of it is about characterising, well, if you have certain resources available, how much can you squeeze into your grid given constraints on the grid and the controls that you have? And ultimately, how do you make best use of that information in terms of planning a grid which is able to absorb that whilst avoiding overbuilding the network? Okay. Very quickly, resilience, largely about climate change. There's a very big project recently finished on that, looking at interactions between climate and energy. Also multi-vector systems, gas, electricity, hydrogen and so on. The new Centre for Energy Systems Integration, which is a partnership Edinburgh, Heriot Watt, Newcastle and Durham, will be looking at in more detail. And the other final part of that work is very much about sustainability and really the focus there on carbon footprinting. Okay, brilliant.
This production is brought to you by the University of Edinburgh.